Good evening, everybody. I'm Jayashree from SNS College of Technology from the Department of Biomedical Engineering. So I'm going to take electric circuits and electron devices. The topic is what? Full wave rectifiers. Let us see what do we mean by full wave rectifier. So full wave rectifier, we have to empathize, right? Which type of rectifier should be used for AC to DC conversion? There are two types of rectifier as we already seen that half wave rectifier, right? So now we are going to see this full wave rectifier. So when compared to half wave rectifier, the full wave rectifier is more complex but efficient but provides smoother DC output. So electric circuits that convert AC to DC are known as rectifiers. Rectifiers are classified into two types as we already know, right? So these are the examples of full wave rectifier circuit. So this 2-pin plug point is burned. This because rectifier circuit, and the solution is what? Stable power supply. It gives the ideal DC supply. If it is a rectifier circuit, the circuit will not burn. So next one, let us see this designing of full wave rectifiers. The full wave rectifier is defined as a rectifier that converts the complete cycle of alternating current into pulsating DC. Unlike half-wave rectifiers that utilize only the half-wave of the input of AC cycle, the full-wave rectifiers utilize the full cycle. The lower efficiency of half-wave rectifier can be overcome by the full-wave rectifier. The circuit of full-wave rectifier can be constructed with the two diodes. In the half-wave, we already seen that only one diode is present in this half-wave rectifier circuit, whereas in full-wave rectifier, the two diodes are present in top and bottom. So this arrangement is nothing but center tapped transformers. Okay. Here the primary winding and secondary winding both are equal. These windings and coils are equally distributed, and this is what the input waveform, left hand side is what the input waveform of this sine wave, and right hand side is what? Half wave rectifier, sorry, full wave rectifier, at which it goes the full wave rectifier output. So from the diode 1 it conducts one half cycle, and diode D2 it conducts the second half cycle. So at the finally we get the output like the continuous half wave cycle at the end of the full wave rectifier circuit. This is what the center tap transformer, which can be connected together like this. It is connected to ground and load is connected to this diode. And D1, D2 are connected in top and bottom of the circuit. We get I is equal to I1 plus I2. So this is what this full wave rectifier circuit, which gives the output as the continuous half cycle with all periods of time. Okay. And next one. So next one is what? During positive half cycle of the alternating current, the top half of the secondary windings become positive, while the second half of the secondary windings become negative. During the positive half cycle, when D1, that is diode D1 is forward bias, as it is connected to top of the secondary winding, while diode D2 is reverse bias because it is connected to the bottom of the secondary winding. Due to this, the diode D1 will conduct acting as a short circuit, and D2 will not conduct acting as an open circuit. During the negative half cycle, the diode D1 is reverse bias and the diode D2 is forward bias because the top half of the secondary circuits become negative and bottom half of the secondary circuits become positive. So this is what the full wave rectifiers are further classified into center tapped full wave transformer and full wave bridge rectifier. So this is what this primary windings in the first half, it is indicated by the AC input. In the secondary windings, center tap is connected to this second half, which is connected as this D1 and D2 diode. But D1 is connected in the upper half cycle and top end of the circuit, and D2 is connected at the bottom of the circuit. So all together gives the output of positive half cycle with continuous half cycle. This is what this full wave rectifier. The center tap is nothing but these windings will go to that secondary windings also. That is what this center tap connection. So next let us see the part 2 full wave rectifiers later. So thank you all. Have a great day.